Let me just repeat what I have said. We have seen so far what a table space is and everything else, and I have mentioned that there are 4 table spaces which are going to be there in each and every database. Now Oracle versions have come from 7 to and even prior to 7 there was 6 and 5 and all that stuff, but since 7 Oracle has become very prominent in the industry. So 7, then 8i, 9i, then 10G and 11G. Currently we are at 11G. There is nothing called as 12, but you must have heard of 12R or R12. This is not a database. Anybody who has heard of R12? R12 is basically their apps, their Oracle apps, which is basically what we call the accounts payable, accounts receivable. All those are applications, ERP applications. They have a different naming convention. They had even 11i, and now they are calling it as R12. So that is a totally different animal. That has nothing to do with our databases. So our databases are only till 11G. Up till 9i, there were 3 table spaces which were mandatory in any Oracle database. Number 1 was system, another one was not Sysaux. Sysaux was not mandatory. Temp and undo. These were the 3 table spaces which each database had up till 9i. After 9i, they decided to add one more table space called as Sysaux. Now let us understand the functionality of each of those table spaces, and then we will come to know what each of those table spaces were and why they added Sysaux table space starting from 10G. So this is our again database, let us say focus 1. Yesterday I mentioned that there are certain schemas which are always going to be there in every database, and what was the first one? Sys. So Sys is an important schema, and then system is also an important schema, and there are some others, and our own schema like finance and A and B and C and all that stuff. Sys is the schema that I mentioned is going to be the owner of all the data dictionary views, all the main tables which are there for the data dictionary views, the views and the tables and certain important procedures and functions which is part of the Oracle software itself. Those are just basically objects, and they are owned by user Sys. And these objects, they are going to be stored in a table space system. So on your hard disk you are going to have one or more data files, and those data files will be there for this table space system. And in that system table space, user Sys will be storing all of his objects. So there is a difference between a Sys as a schema or the user, and there is basically a system which is the table space. So a Sys user is going to create all of his objects which are going to require a specific table space, which are going to require specific data storage, the extension, all that stuff in a table space called as system. System user is also going to create some of his objects in the system table space. So now we should understand, or we know now, the difference between a user named system and a table space named system. Those two are separate things, the names are the same. So user system is going to create some tables, some views, some not views, some tables, some clusters, something which are going to be stored inside the system table space. So that's why system table space is very important, because it contains data dictionary views. Your DBA underscore tables, we have seen a data dictionary view, DBA underscore tables. What is it? It's a view which is sitting on top of certain tables, and those tables are having their extents in this table space. So the first extent of that table is here, the second extent of that table is here, and so on for the DBA underscore tables. That is a view. DBA underscore tables is a view, and the tables required for that are over here. Views don't require disk space, the tables require the disk space. So likewise, all the other tables, all data dictionary views are here. So that is the purpose of the system table space, disk space for data dictionary views. Then let us talk about temp. This is maybe one data file or maybe 2 different data files for temp. This is temp. As I mentioned yesterday, the purpose of the temporary table space is to store the temporary segments, to store the temporary tables. PLSQL developers, or I mentioned like sorting. Any kind of sorting thing that happens will require some tables, some temporary storage temporarily, because they will do a divide and conquer of the sorting things, and that space is required from here.
So we are in this table, PLSQL tables, it means
PLSQL tables and all those are in memory. Though we call them as tables, but they are memory structures. That is going to be inside memory. That is not going to be stored over here. This is only for the data actually. That is also data, but that is going to store inside memory. So that's a different programming concept here. But temporary tables, which will actually have the data. So that is for the temporary table space. Then there is another table space called as undo. Undo table space. The purpose is very, very important. Anytime you delete certain rows from a table. Let us say you deleted 10,000 rows from a table, but you haven't executed a command commit. What is going to happen? Since you haven't executed the command commit, Oracle thinks that you may possibly type the command rollback. And when you type the command rollback, all the data that you have deleted should come back to your original table. So how does the delete work? When I delete 1,000 rows from a table, they are actually deleted from there, and they are copied to some other place, and that some other place is the undo table space. That some other place is undo table space. This is again, in this the extents are there, the segments, everything is still the same. Extents, blocks and all that stuff. So the data that you delete will come inside undo. The data that I delete will also come inside undo. Every user that deletes data will come inside undo. Every user that doesn't update the before image, that means the earlier data, before it was updated, will be stored inside undo. Why? Because if you type a rollback command, then you would get that data back from the undo. That is the purpose of the undo table space, and undo is there for providing the rollback functionality. And then finally the Sysaux. As I said, Sysaux was not there in the previous versions of Oracle 10G and below that. It was introduced only in 10G, 11G and 10G and 11G. There is nothing beyond that. The purpose of Sysaux is to take the load away from the system table space. In earlier days, so many tables were getting clubbed and cluttered and getting crowded inside the system table space. So Oracle decided that there is a distinction between some tables which are very important and some tables that are not so important. Okay, so very important tables are kept over here, not so important tables are kept over here. And what are those not so important tables? Those means there are new products that Oracle is introducing. Oracle has introduced a product called as OEM, Oracle Enterprise Manager, which is a graphical tool to do the management of Oracle database. That is a graphical tool. Since it's a graphical tool, it is going to require a web browser. Web browser is going to connect to the web server. Web server is going to connect to some tables, and those tables are kept over here. So many tools, and OEM is just one example, many tools that Oracle is introducing. So if something goes wrong with Sysaux, will my Oracle database keep on working? Yes, it will keep on working. The only tool will not work. Okay, my database will function properly, tools will not function properly though. So Oracle Enterprise Manager is just one of the examples, and the tables for that, the procedures for that, the functions for that, everything are stored in the, no, obviously, wrong thing. The procedures functions don't require any table space. They are actually not here, only the tables. So that is in Sysaux. So remember these things: system table space for storing data dictionary views. Mostly the owner is sys. Temporary table space, anybody could be the owner. Tables are usually not so important, but used for sorting and all other things. Then the undo is for providing the rollback functionality, and Sysaux is for some auxiliary. That is why it is called a sys auxiliary, system auxiliary. Some additional things. Bolo?
You told about undo that we have, the deleted data is stored in the
undo. Yeah, table space.
But there should be some, that session timeout for the undo, to get refreshed and get some space for other deleted data also.
No, this is a very important question. Let us answer that question here. Okay, now you have these 4 table spaces, or let me draw a little different diagram now. This is your database. This is a system table space here. then system, then Sysaux, then temp, then undo, and you have created one more table space. The name of that table space is just called as TS1, and in that table space there is a user called as Shaker, and he has created a table A which is sitting in that TS1 table space. Obviously there is one extent for this, and there are multiple blocks in there. The data is there in those blocks. Now user Shaker comes in and he says that I want to delete all the data from this table. So he fires a command delete from A and a semicolon. When he fires delete from A, what happens? All this data which is there in A will come and sit in undo. Until what time? That is your question, correct? Until what time it will sit? And my answer to that is eternity. Until the end of the world, which means really until and unless the database is shut down, because you have deleted the data and you must have the ability to get it back. Database must provide you, Oracle must provide you the ability to get it back when you want it. So if your session does not expire, okay, how to expire a session? We have seen that using the profile, idle timeout and all that stuff. If your session does not expire, then you will have this data for you in the undo table space unless and until you type either the rollback command or the commit command. If you type the rollback command, then this data will come from here to here because you want it back now. It was gone from here, you want it back. That is what the rollback command does. If you type the command commit, then what happens? Then you have deleted the data here. You also are not going to require the data because once said commit, you will not get it back. So then at that time this data here is not actually deleted but now is marked as not required anymore. This is called as expired undo. So undo has certain states. First, the undo which is must maintain, nobody should overwrite that, nobody should touch it, nobody should delete that. That is the undo which is required because we have not done a commit. Now once we have done a commit, this undo data is not deleted but it is marked as expired.
So let's say अगर आपका बहुत सारा डाटा है,
हाँ,
उसको हम डिलीट कर रहे हैं, और आपका undo
full हो गया. Yes. So this is one question that we have understood, right? Until what time it will stay? Until the eternity, literally. Now his question is, this table space TS1 is of 1 gigabyte, and there is one big table here. First extent, second extent, third extent, fourth. The 1 gigabyte table space is filled with only one table, all millions of rows. And now my undo table space is only half the gigabyte. So what is going to happen now? The moment I start saying delete from this thing, the delete will start functioning. It will get rows from here, it will put it over here. It will get rows from here, it will start copying the rows from the actual table space to the undo table space. And at some point of time, after maybe 15 minutes, your undo table space is going to be full. And at that time, the data cannot be copied anymore, and therefore your delete statement will fail. Your delete statement will fail, and it will say that unable to allocate space into undo table space. The correct message is unable to allocate an extent in the undo table space, because they are also adding extents there. So unable to allocate extents in the undo table space, and your delete will not work. And this is a very common problem for all the DBS. This is a very common problem for all the DBS because a table space usually which contains data will be very huge in terabytes. You cannot literally have an undo table space of terabytes. So you will have an undo table space in gigabytes. So what to do now? You cannot do it. You have to go and tell the developer that do not delete 1 million rows in one go. What do you tell him? You tell him delete 1000 rows and then do a commit. Again delete 1000 rows, do a commit. So what will happen? The 1000 rows will be deleted, they will be brought over here, and then once I do a commit, this will be marked as expired. And then the next 1000 rows will also come and will be overwritten on the previous one. So this undo table space will never go beyond its need. The space requirement will be never beyond its reach. So that needs to be done. How do you delete only 1000 rows from a table? Delete from a table A, correct? Where row num less than or equal to 1000. That is the command. So you delete 1000 rows but then commit. If you don't commit, again this will not be expired and you will be utilizing this thing. So this is one thing to understand, that undo table space is usually less than the real data and you will have that problem. So delete partially.
Expired means
Expired means not required anymore because you have already done a commit.
there is no size.
No need for that data. There is no need for that data to commit back, to bring it back.
It's just like shift delete from Windows.
It's a kind of shift delete from Windows. Yeah, it has gone from the trash can. You can think, I mean, not the perfect analogy, but yes, it will work. But it is gone now. You cannot bring it back. It is gone.
Okay.
Yeah, actually, it is a good analogy. In fact, I never thought of that. Delete, just delete is basically putting it into undo, putting it into trash can, and then you can bring it back. That is the rollback. You can think of that way also. Yes.
In live database, I don't think undo is very much successful because we can't put our trash data in somewhere which is not committed. In live database, several users uses the same data at a simultaneous, at the same time.
Yes.
If we delete or modify some data, then it will go in undo.
Undo.
Then how can the other user knows that the particular thing happened, the delete function, and this then it will do some contradictory results.
That we will discuss a lot about undo. Yes, you are absolutely correct. Undo is kind of complicated to understand. For example, this is a user A, not you, forget, okay, user 1, there is, okay, let me draw a diagram a little differently. There is user A who has done a delete, who has deleted all the rows from here, and now those rows are here. He has not done a commit yet. So this is an important point to understand. User A has not done a commit yet. At that time, another user comes in, user B, and he executes a command, select star from a dot employee. The name of the, this is a user Shaker. Okay, user is Shaker. There is a table called as A, and this is user Manav. Let us take the names, M-A-N-A-V. And now Manav comes in, table data is deleted from A. Manav comes in and he types the command, select star from Shaker.a. Manav is logged in and he types the command, select star from, first thing, okay, user Shaker says delete from A. All the data is gone from here and kept it over here. Then Manav user comes in and he says select star from A. Not just A, he says Shaker.a. I'm assuming that he has the ability to select from that table the grants and those things. I'm not going to go into the details. Assuming that he can select from this table, what will he see?
He can see the data.
He can see the data or he cannot see the data? What is? He cannot see the data. That is correct answer. Why he cannot see the data? Sorry, hold on. I'm sorry. I'm totally wrong. He can see the data. Yes. I'm not thinking correct. This guy has deleted the data, and since he has deleted, the data has been moved from here to here. Now this guy comes in and he says select star from that table. Which table? This table. There is no data there, but still he sees all the data. Because user Shaker has not done a commit. Because user Shaker has not done a commit. So where does he see that data? If there is no data in table A, it has been deleted by user Shaker, where does he see that data from? He sees this from the undo. He sees that because he goes over here, he realizes that this is a table from which the data is deleted, but it has not been committed yet. So there are certain flags and all that stuff. So user Manav would come to know that yes, data has been deleted, there is no data there, but it is not committed, so the real data is somewhere else, it is not here, the real data is in undo. So that Manav user will go and automatically, without his knowledge, this is automatically done by Oracle, he doesn't have to even know that data is deleted or not, he will be seeing data from here. So we are going to go into details of undo a lot more, but I will mention 2 points here. What is the purpose of an undo? Number one purpose of an undo is to allow a user to roll back the data. Whatever I have done, I want to undo it, and that is why it is called as undo. If I have updated the salary, I want to bring it back to the original salary, I will type the command rollback. So first purpose of undo is to allow user to get the data back, is to allow user to type the command rollback. That is the first purpose of undo. And the second purpose of undo, which is totally underestimated, is to allow some other users like Manav, to see the data if it is not yet committed. To allow other users to see the data if it is not yet committed from the undo. That is what the second purpose of undo is.
But it is not the best practice in the live environments.
No, but this happens now. This has nothing to do with the practice. This happens. You don't have to do anything. All you have to do is fire insert, update, delete commands, and this will happen automatically on our behalf. Oracle will take care of all these things. Our job is just to understand. It will surely happen. Best practice or not, don't care. Things will always happen like this. Always.
We have handled near about 50-60 database simultaneously. So we have to, if we delete some data, we have to commit it that time only. Because the client need to see the updated data, not the garbage or the junk value.
That is correct. See, so that's why a DBS will get very much frustrated if a user shaker goes and deletes the data and then he goes for a coffee break. He comes back after 2 hours and then types the command commit. Okay, that is, user will get very much upset with that. Why? Because he is unnecessarily holding this much of space in undo, and he is again decreasing the performance of Mr. Manav, because Manav has to go and read from undo. So the moment you change it, if you are sure that it is a correct decision, if you are sure that you want to delete the data, you delete it. You do a commit. Yeah, you do a commit. But I will tell you, PLSQL programmers, the yesterday's program that we saw is adding 1 million rows. Okay, 1 million rows in a table. We are doing it in a PLSQL loop. One insert, then the second insert, third insert, fourth insert. As we are adding data, just like delete, when we do a delete, all the data has gone from here to here, and when we type a rollback, it will come from here to here. But for an insert, as we are inserting data here, and after that insert, I type the command rollback. What should happen? All that data should be wiped out. So on the undo, okay, there is a row ID there that is kept, and we'll talk about row IDs later, but there is something also called as row ID on the undo side, so that with that help of row ID I can get rid of the data if I type rollback. Okay, we'll go into that detail much later, but now the point here to understand is that in a PLSQL program, when there is a loop, if you start doing a commit after every row, then the PLSQL program is going to be immensely slow. And therefore you do a 1 million insert and then do a commit, then the remaining 1 million. So likewise, if you want to insert 10 rows, or if you want to delete one row at a time, you do a delete of 1 million time, you do a delete and then do commit only once. So that will increase the performance. So yes, there is a trade-off there. Commit should be done more frequently from the DBS point of view, and commit should be done less frequently from the developer's point of view, because the performance will increase.
Just because developers need to work more if you do commit.
No. Developer's performance goes down. A program that developer has written, it will take 1 hour if the commit is done every row. But it will take maybe 5 minutes only if you do commit only once. That is what so developers are going to say, because of the DBS forcing me to commit every now and then, my program is becoming slow. So developers will not do commits every now and then. They will do commit only once at the end of the program, which is bad from the DBS angle. So there has to be the DBA should understand this problem from the developer's point of view, and developer should understand this problem from the DBA point of view. But that will go. I mean, yes, DBAs will always frown upon you if you don't commit. They will always do that.
So is there a condition when we insert any row, so first it is kept in the undo segment?
Not the entire row. When you insert, the row actually goes here. But the row ID is the unique identifier of that row, is kept inside undo.
If it goes in that table, in that tablespace A, and if it is inserted by Shaker, and then we fires a command by Manav,
select star from A,
Shaker.A,
Shaker.A,
then he won't see
any data. He won't see any data. He should not see. Oh. But because he has not done a commit.
It is kept in that tablespace, no?
But yes, so there is data in this table which is not yet committed. And since it is not committed, it will go and do it from the undo. It will find out what rows are not committed. It will get the rows IDs, and those will not be displayed. So undo plays a very crucial role for Manav, because Manav has to see somebody else's data, or the data which is uncommitted. And Shaker, it is very important because Shaker might change his mind and might say undo, might say rollback. Okay, so we'll stop.